Hello, and thank you for tuning into the Math Guy. Today we'll be looking at probability and odds. Our first problem today reads, you rolled a six-sided die. Find the probability of rolling an even number. Alright, in this problem we want to find what is called a probability. A probability can be found by taking the number of desired outcomes and dividing that by the total number of possible outcomes. So for example, in this case, we rolled a six-sided die. There are a total of 6 possible outcomes. We could have the number 1 show up, we could have 2, 3, 4, 5, or 6. That's 6 outcomes. So for this probability, the total number of possible outcomes is 6. Now we need to figure out how many are even numbers. So we have even numbers of 2, 4, and 6. That's 3 outcomes. So the total number of desired outcomes, or the number of evens, is 3. So the probability of rolling an even number on a six-sided die is 3 out of 6. The only issue is, whenever you have a probability, you always want to simplify the fraction. So in this case, we divide both the numerator and denominator both by 3, and we get 1 out of 2. If we want, since it's a probability, we can rewrite it as a decimal, which is the same as 0.5, or most commonly seen for a probability is to write it as a percentage. 0.5 is 50%. So any of those 3 answers is correct for the probability of rolling an even number on a six-sided die. Our next problem today reads, the school is having a talent show that involves 8 acts or groups. The order of the performance is random. What is the probability that the acts will be performed alphabetically by their last names? So we have, just like before, is a probability. We have a probability. It's going to be something over something, where it's going to be the number of desired outcomes over the total number of possible outcomes. Well, the first one we're going to look at is the desired outcomes. This is the easy one to find. We want the desired outcomes to be alphabetically in order by their last name. Now if you went through and put students or famous people or anybody in alphabetical order by their last name, there's only one way for that to occur. It's not like there's multiple ways to put people in alphabetical order by their last names. There's only one. So we know for this probability, it is going to be 1 over something else. We just need to find out what that something else is. This is the total number of outcomes, in case you forgot from the last problem. Okay. Total possible outcomes. So we need to figure out how many ways we can put these people in a random order for these 8 acts. So what we have to actually incorporate some of the other things we learned about already in class. What we have to do for this one is we need to figure out the total number of ways to put something in order. Okay? Now, because if this is the case, the order matters. So when the order matters, we have to use what is called a permutation. Okay? Whenever order matters, it's a permutation. The order matters in this example because everybody goes. It's a different type of order. So, for a permutation, we need to know what n is, and we need to know what r is. In this case, we have 8 acts. So we're picking from 8, and we want to have all the acts in the show, so r is also 8. So we have a permutation of n equals 8, and r equals 8. So for this problem, we have 8 permutation of 8. This is the same as 8 factorial over the quantity of 8 minus 8 factorial. Well, we know that 8 minus 8 is 0 factorial. So we have 8 factorial over 0 factorial. We know before that 0 factorial is the same as 1. We type into our calculator 8 factorial, which is the same as 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. This gives us an answer of 40,320. 40,320 divided by 1 is simply 40,320. So our probability uses this number as a total number of possible outcomes. So you have 40,320. So the probability of these students being put in alphabetical order by their last names randomly is a 1 out of 40,320 chance. Our last problem today reads, a card is drawn from a standard deck of 52 cards. Find the odds of drawing a 10. This problem tends to be a little tricky, mainly because of the fact that we haven't really talked about odds yet. The last two examples went over probability, which, if you remember from the last two problems, probability is the number of desired outcomes divided by the total number of outcomes. Odds is a little bit different. Odds is the number of desired outcomes divided by the number of undesired outcomes. So if you look, instead of having the number of desired outcomes being divided by the number of total possible outcomes, odds is different mainly because of this denominator right there. So what we have to do is work around a little bit differently and think more about what's going on. Odds are mainly used in gambling and betting to try to trick the people into understanding what's going on. And most people that don't know the difference between odds and probability usually see odds as a better probability than what it actually is. So it's mainly meant as a way to be out there to trick people into seeing something differently. So in this case, we have to find out the number of desired outcomes and the number of undesired outcomes. So the first one we're going to start with is the number of desired outcomes. We want to find the odds of drawing a 10. So we look at a standard deck of cards. In a standard deck of cards, we know there's 4 of each number, which means there's 4 tens. Because of that, the number of desired outcomes is 4. So the number of desired outcomes is 4. There's 4 ways to draw a 10. Now the number of undesired outcomes is a little bit differently. We know that 4 of the 52 are tens. That means there are 48 other cards. The 48 other cards are the undesired outcomes. They're the cards we do not want to draw. So for odds, the odds of drawing a 10 is 4 out of 48, which we can rewrite this as 1 out of 12. Odds are usually more commonly seen as being written like this, 1 with a colon, then 12. That's usually the way you'll see odds written. Either of these two forms is correct. Thank you for tuning in. Remember to check back again soon for more videos by me, the Math Guy.